Here we have another example with a limit as x approaches infinity situation of our given equation. So whenever we're being asked to find the limit as x approaches infinity, remember that that's really another way of them asking you to determine the horizontal asymptote in that direction, or the long-term behavior of the graph. They'll use all of that sort of interchangeably. Normally what I would do on this is just the quickest way possible, which is just doing a top-heavy, bottom-heavy, or balanced situation. But oftentimes in class, you're asked to sort of show that this is the answer. Usually you can look at these and in about 2 seconds know what the answer is. And so whenever we need to do it the long way, then we have to do this process of dividing by the highest power of x. So divide by the dominant term is what I like to refer to it. So divide by the highest power of x, the entire equation. So as we look through our equation over here, we've got an x to the fourth on top, an x squared, an x to the fourth on bottom, and an x cubed. Here we've got x to the fourth is going to be our dominant term. It doesn't really matter which one you choose. It's the highest power of x, and so you're going to divide every term by that highest power of x. So what that will look like is we get the limit as x approaches infinity. Always keep that limit statement coming with you when you're doing this work. So we'll get 12x to the fourth, divide that by our highest power, x to the fourth, plus 128x squared, and then divide that by x to the fourth. All of that is over 7x to the fourth divided by x to the fourth plus x to the third divided by x to the fourth. Now what you want to do is you're going to come through and you're going to simplify this equation down. And you're going to simplify it using a definition that they like to give when you're working in this section. They give you this definition that the limit as x approaches infinity of 1 over x equals 0. We're allowed to use that definition to quickly simplify that limit equation. This works. It's not just limit as x approaches infinity of 1 over x. It could be 1 over x to the fifth. Anytime you've got a number over x to a power, that thing is going to head to 0. And so when you come back through, you simplify it down real quickly by first canceling out on this top piece. You've got x to the fourth and x to the fourth cancel each other out, and that's going to leave you with just a 12 for that first position. We get plus, and then on the second term here, x squared is going to cancel out 2 of the x's from down below. So you're looking at 128 over x squared, which does fit this definition. And so generally what you can do is just sort of draw a line through it and say that that's going to 0. So then you put your plus 0 there. On the bottom, we again have matching x to the fourth and x to the fourth. So those are going to cancel out, and that's going to leave us with a 7. And then on this last piece here, all those x to the thirds are going to cancel out with everything but 1. So you're really looking at 1 over x. Again, that definition that we get to use, which tells us that this goes to 0. Now what you want to do is you just want to simplify down that answer. So we have 12 plus 0 over 7 plus 0. That's going to simplify down to being 12 over 7. So that's our final answer for this limit. The limit as x approaches infinity of this equation would be y equals 12 over 7. Remember, the answer to a limit problem is always a y value. It would also tell us that the horizontal asymptote as x heads to infinity would be that same y value, 12 over 7. That's our long-term behavior. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.